name is Andre Madan. I'm actually the person who's supposed to give in this talk is Arthur, and he's in those books that you have. He's not, unfortunately, he couldn't make it. So I am going to be giving my version of the talk about testing. And the talk is going to be about testing, and I'm very surprised to see so many people at the development conference actually show up for testing talk. So thank you for that, especially after lunch. I appreciate you all being here. I was a developer for 10 years, and I was working at a medical device company called Medtronic. And that's where I was doing a lot of test environment development and a lot of unit testing, a lot of environment. I wrote a couple of frameworks for unit testing, and I also wrote framework for functional testing. So now I work for Parasoft, and Parasoft is we just basically write software that helps you to test your software. So it's a test automation, defect prevention software. So for everything else, I'm going to stop talking about Parasoft. You can go to parasoft.com and learn about Parasoft yourself. This talk is not about Parasoft. This talk is about testing. And unfortunately, Arthur couldn't be here, but I feel that I have visited, in the past year and a half, I visited maybe 80 to 100 different customers in the Midwest. I'm a solution architect, so my job is to go and visit customers and talk about their challenges. So I've seen plenty of challenges today, and I will be talking to you about how to potentially solve some of those challenges. All right, so if anything you will take away from today's talk, from my talk, I want you to take away 3 things. So when you walk out this door in an hour, I want you to remember just 3 things. First, think about the metrics that you will apply to your tests to decide are they useful or not. Second, throw away the useless tests. Just remove them from your repository. And third, based on your metrics, write new tests that you will maintain. That's it. That's what I want you guys to, when you walk away the door, those 3 things. Think about the usefulness, throw away the useless, and add the useful. Very simple. And for the next hour, I'm going to be talking more about those metrics. All right, QA. How many people are here from QA organizations? I know my friends in the back there. Now, who's from development? Aha. And you're still in the same room. So it's impressive that in today's world, what I see the shift in the mentality is that QA now becomes part of the development. QA, in order for you to deliver the products faster, deliver the software faster, QA needs to be involved in the very beginning. Even if you don't want it, it's a reality of life. That's what's happening today. All right. However, another thing that happens today is Agile. So it's another buzzword. Everybody's trying to figure out what it is. There are Agile consultants you can hire. There are Agile books, Agile this, Agile that. But basically, the idea of Agile is to go faster with more stuff to do. So when you put more stuff to do, the unimportant stuff fails off. Like if my wife tells me to do, let's say, 10 things, I cannot do like 11th thing, right? So something has to go. So normally, unfortunately, testing falls out. So in Agile development, testing just sort of people, we'll do it after. So in this little car, it shows that testing piece will eventually fall out. So what do you need to do to become continuous? Now everybody, let's talk to you guys, right? Everybody wants to be continuous nowadays. Continuous testing, continuous delivery, continuous deployment. Well, before you start talking about those continuous things, you need to actually automate your testing. Without the test automation, without making sure that you push a button, not even a push a button, show up, in the morning, you see the test results. You need to automate your process. Without that, everything else is gibberish. Forget about continuous stuff. All right, I'm just going to quickly run through that because I don't want to go back and forth every time. So, importance of testing Everybody knows the importance of testing. Otherwise, this room would not have a single person. So the testing is important, and everybody says that's important, but not everybody does. We're going to talk about different levels of testing. Here is like testing unit and functional. So how many people here do unit testing as practice? How many people have 100% of the code coverage? Is it regulated environment, FDA or DoD? So you just do it. Wow, I'm impressed. It's line coverage or branch coverage, statement coverage?
Pretty much line coverage.
Line coverage. Okay, we're going to talk about coverage and the usefulness of that metric from my perspective. Just kind of a side note, in the regulated industries, some regulated industries like FDA or DoD or avionics or automotive industry 26262, they require coverage. DO 178B specifically says MCDC level of coverage. So there's really no questions, like you need to cover that. But for the rest of the industries that are not regulated, like retail or banking or I don't know, travel industry, whatever, that is where people are iffy about the coverage. And coverage is one of my soapboxes, so I'll talk about that later. Well, unfortunately, testing is often ignored. I'm guilty as charged. I used to be a developer, and I would write my unit tests after I wrote my code, maybe a week after or whatever I feel like. Especially true for developers that are ignorant and self-centric, like myself. I used to think that I'm the god of coding. I knew C++ in and out. I knew C in and out. And I made mistakes that taught me not to be ignorant and egoistic. So before you make those mistakes, you're kind of where you are. So this developer ego, I used to be one of those guys. So we're going to be talking about 3 levels of testing, 3 ways to test your software. Unit testing, which is testing the smallest possible composition of your program. Sometimes it's a function or a method, and sometimes it's a collection of functions. You define what your unit is. Functional testing is, actually I have a definition of that. Functional testing is when you test, does the software work per your requirements, right? And the regression testing is something that tells you, did you break anything? So it's different levels of testing that serve different purposes. So unit testing validates, is your method or function behaves the way it's supposed to be behaving under different conditions. So when you guys write your unit tests, do you write use cases for error handling? Yeah, so normally it's very hard to inject that error at the functional level. So if your software is operating, let's say, in an operational state, right, it's really, really hard to inject that error code in there and then see if the software responds. So it's a good idea to actually test unit tests under different conditions, both negative and positive. Here's the big debate that I see with everybody. Does unit testing provide value? Who thinks that unit testing provides value? Who thinks that it doesn't? It's more people. So it's more people who believe that unit testing does not provide value. Your managers, your VPs, directors are in that camp. They feel that it's just a waste of time. And here's the argument. Look, guys, if you're a developer, you tell me that you have 100% unit test coverage, you tested your code, you achieve 100% of line coverage or statement coverage, do you have bugs in the code? And the answer is yes, exactly. Opposite is true. So if you haven't unit tested a single function of your code, all you did is a functional regression testing at the higher level, will your software work? And the answer is yes, it will. It will fail sometime, more often than not. But the argument that management is making is, look, guys, you are wasting the time. And we have to convince them that it's not a waste of time. It's actually provide value. My personal opinion is I'm not like in the camp where I 100% believe that 100% of unit testing, 100% of line coverage or MCDC coverage is what you need to do. I don't believe that. Actually, what I believe is the process of writing unit tests brings you huge amount of value. Just the fact that you stepped out of your development kind of mentality and look at your method or signature of your method or look at your function that you wrote under different lenses. And you start writing those conditions. So this is often not being thought of when you present that to your management, say, hey, we need to do unit testing. The fact that you're just simply writing the unit tests, that's a huge value to you. I personally found more bugs in my code when I wrote unit tests when the unit test was running. Unit test is running, I know it's passing, I mean, I wrote the code. But when I was writing, it's like, oh, holy crap, oh, how does it, so I would rewrite my code while I'm writing unit tests. Once the unit test is written, I might as well not check it in because I know the code kind of works and it was well refactored. So this is my opinion. It's not an opinion of Parasoft. It's Andre Madan presenting findings over 14 years of doing that. All right, and the functional testing has many flavors, as you can see that. Even the unit tests today can be traced to functional testing. So for example, if you're testing a particular algorithm, you can make sure that this algorithm works per your requirements. So even the unit test can be a functional test. There are different flavors. Some of the good ideas to take away from here is how to create those functional tests. Sometimes you take a requirement, and you look at the requirement and you go ahead and write the functional test. Or sometimes you can actually run your software, generate some traffic, and one of those things is capture that traffic and then generate tests from there and then expand on them. So there are different ideas. Yes, there's a question?
Well, do you want questions now or at the end?
Oh, now it's fine.
When you talk about unit tests, you say a few words about unit tests that are difficult, that you have to run mock objects to actually get the test to work.
Did I say that or will I say that?
No, can you talk about what I would do in cases where I have to put a mock object in?
Oh, okay. Yeah, so slightly different topic, but the question was, let's talk about mock objects. Let's talk about best practices about mock objects. To me, kind of in my head, unit testing comes down to three things. How do you define your test harness? How do you stub or mock the objects? And how do you collect the code coverage? If anything, I can boil everything down to those. Some people use CPP unit, some people use JUnit, there's Google tests now, there's just a whole bunch of frameworks, but they're all boiled down to that. So for the mock objects, that's really a pain in the butt. Let's just admit it. Stubbing out stuff is a pain in the butt. So especially if your software was not architected to be decoupled, right? Sometimes I've seen architecture where it's like spaghetti code. You know, function calls this function and the parameters are not being passed. It uses some global variable here. You read that variable and it's just a mess, right? So mocking those is a hard thing. One of the best practices that I found for myself is do some metrics. So for example, coupling between objects, you can run a metrics and see, and you can require in your organization to say, we're gonna keep that coupling metric or cohesion below a certain threshold. And this will help you with mocking down the road, right? So but it's a pain in the butt. It's just, let's admit it. Stubbing is a huge problem. There's no good framework that I use that I found for stubbing. Who uses, which frameworks do you guys use for stubbing? Makito, yeah, that's a very common one for Joe. What? Spock?
Yes.
Sign on? Right on. So let's share it. I mean, what other frameworks for stubbing do we know? JMarket. What's that? Howdmark? PowerMark? Yeah, so as you can see, there's tons. But I haven't found the good one. Where I wish the mocking stub of, tell me if you know this exists. I don't know. But what I'd like to do is I'd like to define my unit under test, and I'd like to define it somehow, run that unit kind of in operational state, and this software, whatever magical software that nobody wrote yet, will actually monitor all of the calls and all of the data accesses from that unit and create me the stubs automatically. Does that exist? That would be so cool. That would be like my dream tool to use. Just, okay, this is my unit. Let's run some stuff. Automatically generate stubs, and it will create me test data and all of the return parameters. Oh, I would just buy that tool in a heartbeat. Unfortunately, Parasol is not here yet, but we are getting there. Any more questions? Thank you for questions. Yes.
Like for example, when you want to attack like a monolithic app, like where you're talking about this spaghetti code. Are you gonna give us an example of that? How to attack that?
Tough luck. So, yeah, did I answer your question? So everybody struggles with that, and it's a trade-off, right? So the way I would approach it is, first of all, not do unit testing at all. So let's not figure out the unit. The way I would approach is run your functional tests and collect the code coverage on that monolithic block, and see what you did not cover, because those are the most dangerous points of your code, the ones that are not tested. Okay. Then you look at, okay, so I got the code coverage. Let's say I got 35% of the code covered on the functional tests. Oh crap! What is that? Additional 65 that I didn't, or whatever, right? So that's how I would approach it. Decide first of all why you want to unit test it. Where's the problem? And then solve the problem. Don't unit test for the sake of unit testing. It's useless. You're gonna find so many enemies. So prove that what you do has value, and then do it. Did I answer your question now? But it's hard. Refactoring, so we talked about re-architecting. I don't know this probably. But re-architecting software is one option. But re-architecting the software is really hard to sell to the management. So you're going to do what? You're going to spend like 6 months doing absolutely nothing, produce zero value to my customers? Is that what you just said? And you're like, yep, out. So I've been there, done that. Yeah. So regression testing, we want to focus on regression testing. Why? Regression testing, everybody. Unit testing, the opinions are split. Some people believe it's useful, some people haven't done. Everybody believes that regression testing is useful. There's no person I met in my life yet, maybe I will today, that will say, oh, regression testing is the most useless thing ever. Do I get to meet that person? No, I thought so. So regression testing, even if, like I'll give you an example. In one of the customers, they used very old compiler. So that compiler had a limit, internal limit that nobody knew, it was unsupported compiler, on the number of lines in the file that it can parse. So what did that one person do? It added 5 lines of comments. It's just comments, come on, I'm doing a good thing. And never ran anything, checked in the code, lives on vacations for 2 weeks. The next morning, build breaks. And the guy was like, well, he comes back from vacation, and guess what? He is in a very difficult spot, explaining how did he break the build before leaving? Didn't you build it? And he's like, no, I just checked in a couple lines of code, or comments. I'm sorry, comments. So that was, and the compiler just puked. It didn't even produce any message. It was just stopped, and that's it, like core dump or something. So regression testing, very important. All right, so we're all smart people here, I hope, except me. And then we all know what the difference between now unit functional testing or regression testing. So unit test if your software doing the thing that you think it will do, and then functional testing will actually test if it works per your requirements or specifications. And regression test looks at if you broke anything or not. Why do unit testing? We talked about unit testing quite a bit, so I'm going to just skip that step. Famous slide, whatever. Everybody knows that finding issues earlier actually benefits you not only from time perspective, but also money. It's more expensive to fix bugs later. I was just leaving, and then my kids, when I was leaving my house, my kids made a mess, right? So before going to sleep, right, they made a mess. They just put everything out. All the toys were on the floor, and I told them, hey, clean up, you know? And they're like, oh, no, we'll clean up tomorrow. Right. Just do it now, and then do it today, because that's still fresh in your memory. Similar with testing. When you test something and you found a problem, you know how to fix it because the code, that algorithm that you've been working on is still fresh in your mind. So it's really easy to fix. Fixing it later not only will be more expensive, but now you have to find a developer who put that bug in, and then maybe he quit or whatever, got fired, and then figure out what's the right fix. Once you fix that, chances are that you actually broke something increases. So finding defects earlier, it's been proven that it saves you money, and money what your management wants to hear.
You're missing a category
Which one?
in requirements, writing requirements. You can find a bug before there's even any coding.
Requirements testing.
That's even cheaper.
Absolutely. Yeah, I didn't talk about, it's a good point. I didn't talk about requirements testing, but actually probably I should. So I would want to talk about requirements modeling. So building a model of whatever you're building before you're building that stuff and giving it to the customers kind of in a sketch or whatever. Say, hey, validate that this is what we're building before you actually start writing software for it. That's a very useful method. Kind of a validation, requirements validation. And requirements verification means that are we actually doing the stuff that we're doing? So those two methods, requirement validation and requirements verification, is a very important step. Fortunately today, when QA and Dev come together, that step and BA, that step actually all of a sudden becomes a necessity. Because you have to have a model for you to go test and for you to go code, so people conversion that idea. Yes, very valid point. I got this slide from a while ago from Arthur. So Arthur, if you're watching this. All right, so some of the best practices I'm going to share with you. And again, feel free to chime in. Unit tests, oh my God. They are pain in the butt to maintain. Because the second you change the code, chances are that you broke your unit test, even though it was a valid change in the code. So now you have to, when you think about refactoring a large kind of monolithic block or whatever, think about all of those unit tests that you're going to break and then you're going to have to fix. So maintenance of the unit test is a necessity. It's just, but it's a lot of work. So you have to keep in mind that the second you wrote a line of test, you will get stuck maintaining it. So if you're not planning on maintaining the test, don't even write that line of code. Did I cover? Yeah. So it's a good idea to automate your testing process. And the first thing you can do is if your testing framework runs from a command line, just put it in your Jenkins build or whatever as a build. It's just a good best practice to do it. Why? Because sometimes when you check in the code, you run your unit test, you found that you broke something. Like that example that I gave with the compiler, you know, that would catch it. Unit tests wouldn't work for that one because unit tests will have to be compiled with the same compiler. All right, so some of the things about the unit testing that you should remember is maintainability is a great cost, but also assertions. So let's just talk about assertions a little bit. If you don't write any assertions in your unit test is pretty much useless. Well, it may find like a null pointer or something like very drastically crashing, like a program crashing bug, but that's about it. Or if you write too many assertions for every single like data variable that you want to verify, every single inherited property, you are just doomed. So the truth is somewhere in the middle. That's it. So you have to be careful about assertions. So legacy test suites. This is interesting, right? When a new management comes on board, new architect is like, we are going to just throw away all of those tests and we're going to write the new ones because the old tests are crap. Well, truth is that nobody likes legacy. Nobody likes to deal with the old crap. However, there is something in those legacy tests that may be useful, which is not documented in requirements, and it's not written specifically in the code. So some of the assumptions about how the code operates, it's not commented in the code, it's not in requirements, it's in the test. So be careful with the legacy test suites. You know, the things that parents told you. With age, I figured that those things were actually true. So legacy is important in my experience. Don't just start from scratch. A lot of people are saying, oh, we're going to throw this code base away, it's old, and we're going to just start architecting this whole new thing. It doesn't work like that. The revolutions never work. I'm from Russia originally, hence my accent. Revolutions don't bring you anything good. So gradual, care and slowly kind of refactoring your code into something where you want to be. That thing is actually working. So that's just my opinion. All right, so actually creating unit tests is easy. We have a software that just automatically creates you a whole bunch of unit tests with all sorts of auto creation of unit tests is a solved problem. Maintaining those unit tests is not an automatic thing. It's not solved yet. I haven't seen that solution. So be careful. You're going to be stuck maintaining those unit tests, the ones that you're creating. So coming to your management says, I've created 100 unit tests. All right, good boy. But then you have to maintain them. Think about it. Time check. How much time is it? All right, so I'm half an hour. OK. I'm actually finished early. Are there any questions so far? Comments? People are leaving now, so they're like, screw that. I have to do work. Yes?
I have a question, something on a slide, a couple back.
OK.
You mentioned that it's realistic to have more like 80% coverage instead of 100% coverage. And I totally understand that. But I'd like to ask you about expecting 10% failures.
Aha. This is very important. Remember those three things that I mentioned? Think about the metrics. Test failures may be one of the metrics. So some tests are really noisy. And the problem is that people accept that. So let's say you run your tests, both functional and unit tests, and then how do you decide when to ship the code? Do you have to have 100% coverage? So some tests are noisy, and unfortunately the reality is that people accept that reality and making decisions, that test has always been failing, that's fine. Well, the problem is that it's maybe not fine. So the way to look at that data is realistically, that's what people do today. The way to look at it. Realistically, they look at, I got out of the 100 tests, 93 are passing, I got 80% code coverage, and those 7 tests are always been a pain in the butt, but it always works, so that's fine. That's reality. Okay. So
that's where you would say maybe eliminate those tests.
Exactly. Thank you. You're just to the point. What I'm saying is eliminate the noisy tests. That's just, they don't provide any value to you. But be careful. So in some industries, you can get actually sued or have some litigation aspects if you remove those tests. So when you remove the tests, you want to make sure that you document that process, review that, and check it in somewhere. So that if they come and ask, hey, your software killed somebody, did you test it? And you're like, yeah, but some of the tests failed and you removed them. And nobody's going to ask you, did those tests actually provided any value at that point? But you have to have a documented kind of a cover your butt type of scenario.
Just to reply quickly, my company's pretty soft on the code coverage requirement metric, but we're pretty firm that 0 tests can fail. If you've got a test failure, then someone's going to come down and yell at you at your cube. And those have to be working.
Thank you. Yep. So code coverage, I have 2 soapboxes, right? One is the unit testing, another is code coverage. So the code coverage, personally, I don't believe that achieving 100% code coverage at MCDC level, at the unit level, is a valuable thing. Personally, I don't. And the reason I don't believe that, because people tend to think, I covered every line of code, the code must be working. That's a mistake. So because you achieve 100% code coverage, it means absolutely nothing. But, so most people, what they do is they say, okay, You achieve 80% of the code coverage, that's good enough. The problem is that in the next run, you got 80%. Is it the same 80%? Or is it different? That's the question you need to be asking. All right, where was I? What was I thinking? Okay, so another thing is, what I want to mention is write tests with the code. Some people do TDD. Who does TDD nowadays? Yeah, so some people do waterfall and write test software. So it's really like up to you when you want to write the tests. I personally have no preference. I once did TDD approach, then we did not do TDD. I see it both ways, so I have no preference. However, what I do prefer is that write tests in the code in the same, at least in the same time frame, so that you remember what the code is doing. So you put some comments in the test, kind of documenting the code. So what you end up doing is actually making your tests useful for the next person who's going to come on board. Think about other people sometimes, you know. So who works at the regulated industry where, you know, FDA oversees you or government like DOD? All right. So in some of the organizations, like I used to be working at one, every code, every requirement, everything has to be traced to a test or a code where it was implemented. So sometimes it's useful to test a requirement at the lowest level possible, because that's where you can test it in isolation, and those tests are probably going to be more robust than the bigger test. And if you can cover that algorithm or something logically happening in the code, in the unit test, you know, be my guest, tied to requirement. Put some comments in the code, or maybe during the check-in, you teach your version control system to recognize those tags. So during the check-in, you make it part of a process. So building the traceability is work, but sometimes it provides you value and saves you time when you do functional testing. Now you don't have to retest that algorithm. So just think about it. All right, I talked about that. That's the thing. I talked about the 100% code coverage. It means, to me, it means absolutely nothing. The good idea about the code coverage, actually, it's on my next slide. Yes, this is what I want to talk about. The good idea about code coverage that I start seeing in some customers, they combine the code coverage. So the first I mentioned, like you first run a bigger kind of a functional testing suite and collect the code coverage, and you fill the gaps. You look at where your gaps are, and you either add tests there or you add unit tests around those gaps. Most of the gaps, believe it or not, happening at the error handling. So nobody tests error handling. Everybody tests sunny day scenarios. Rainy day scenarios are often overlooked. So that combining that code coverage exposes those untested fields in your code, untested areas, untested files, or even lines of code. So what I've seen being very pragmatic approach in one of the customers I had is they run the functional tests. They needed to prove to FDA that they've executed every line of code. So okay, so what they've done is they run a functional test, look at what the gaps are, and then write the unit tests. Now those unit tests are meaningful, and combining code coverage is 100%. Well, look how much money they're saving by not creating stupid unit tests. Nobody likes to create unit tests for no good. So they've done it, FDA bought on it, well, they're good. All right, code review. If somebody put a gun into my head and say, Andre, choose one of the two things for your team. Either they do unit testing or they do code review. Which one, and the gun is there, right? So which one will you pick? You need to pick one. Personally, I would pick code review. Because code review is like a free quality assessment tool. It's before you show your code to everybody, you want to make sure that this baby is right. You want to make sure that all of the standards are followed. You want to run static analysis. You are actually doing a lot more work, more than the unit testing will show you, to beautify the code, to maybe re-architect it to look a little nicer. You put the comments in the code. So you take care of your code before you show it to anybody. Same thing with the tests. And the interesting part about reviewing the tests, it brings you the level of kind of a team cohesion, so to say. So when somebody leaves, the next person will actually know what those tests do, or at least have some idea about where to find things. If you wrote your unit test and didn't tell anybody, and you left the company or moved on or whatever, then the next person around will be looking at the code. The code is pretty self-explanatory. You have requirements, so you read the requirements, you read the code, you kind of figured out what it's doing. There's no requirements for the tests. So most of the time, people are like, oh, screw that old legacy test suite. I'm going to write my own. So that creates extra work, and for the management, they don't like it. So reviewing each other's tests is a good practice, and if you can do it, do it. So for example, my wife stores kids, like I have 2 kids, and my wife stores their clothes. She's the only one who knows where the clothes are. And I'm like, there are boxes, and she once told me, hey, go get whatever this for the kid. I'm like, where? So unfortunately, let's say she left for a couple of days over the weekend to do the camp with girls. And then I was left alone, and I didn't know where things are. All of a sudden, it got a lot warmer. I'm from Minnesota, so things got warmer there sometimes. And then I didn't know where the summer clothes are. So I had to call her. She wasn't available, so I'm like, well, we're gonna stay home. So the rule of thirds. Everybody tests a sunny day scenario. Nobody tests error handling. So test exception handling is always, in my experience, skipped. And the interesting thing is it's kind of hard to test. Like if you're doing the functional testing, how do you put the system in a state where it's not supposed to be by the requirements, right? So error handling is a lot easier to do at the unit level. You put the unit, you inject some errors at that level, and it's just a lot easier. So cover that error handling at the unit level. All right, assertions. The problem with assertions is that it has to be very specific. So it cannot give you the maybe answer. Did your unit test pass? Maybe. It's not going to work. So assertions are there to verify that the code actually does what it's supposed to do. But be careful with assertions, because all right, so assertions tell you if you introduce the coding errors. But be careful with that. I think it's on my later slide, because people tend to write too many assertions, basically. People tend to just go nuts. And that creates the maintenance hassle down the road. So write just the right number of assertions. And when you review, I talked about the importance of code review or test review. When you review each other's tests, make sure that one of the questions that you're asking your peer is, why are you checking that? And another question is why you're not checking this. So those 2 questions. So that's another thing. The ease of creating assertions leads to poor. Everybody knows how to copy and paste. So you just copy and paste 5 lines of code, and you edit. Oh, I'm going to check on this variable, so you look good. So I wrote like 5 assertions. As a matter of fact, it's just one variable being modified by that method. Everything else is inherited. But people tend to do that. It's stupid. All right. So when you do the cleaning, and one of the 3 messages that I want to say here is clean up your assertions and then remove the unnecessary testing. Just remove it. So some of the assertions, like I've seen my software behave differently on specific machine. So machine ID for me was kind of screwing things up. So those assertions are not necessary, because that will lead to your code or your test suite being not very maintainable, because it will lead to the noise. If the test passes, if the 100% of the pass results cannot be achieved, that leads to noise. And just remove those assertions. They're not needed. Well, sometimes you find bugs in the code. So once you found the bug, make sure that this bug then, after you fixed it, has a test that verifies that you fix the right thing and you're not going to make that mistake again. So that's what this is all about. Write new tests only when necessary. Well, cleaning up the test. Nobody likes to clean up, but from the management perspective, this whole testing is very expensive. The management doesn't like testing. They want to release products. They're not releasing tests. They're not selling tests to the customers. Well, unless you're like a staffing company or something. So you're selling products. So they're interested in how well your product works, not how many tests you wrote. So unfortunately, most of them thinks that that's just, it's something developers and engineers and QAs, they have to do it. They have to go to the bathroom and they have to write the tests. So, I have to provide those two things to them. That's the way they think. All right. So unfortunately, one of the challenges that people have today is they write unit tests and some of them fail. So don't write the tests if you're not going to maintain them. That's a simple message. And one of the three things I said, in the spring or in like when it's a kind of a low period of activity, I know nobody in the crunch time thinks about cleaning up your test. But sometimes, let's face the reality, sometimes you're not as busy as always. So in those times, I propose cleaning up your tests, looking at the ones that you haven't run for a while, maybe 2-3 weeks or months or years, and maybe removing them from the repository, moving them to archive or something like that, because they will become your enemies when the crunch time comes. Yeah, that's one of the messages of this talk, is remove junk, basically. Some tests are noisy, some tests are really unnecessary, but be careful because you may be audited, and just you have to document that you remove those tests. You want to do this cleaning actually routinely. So one of the things, if you're doing Agile or whatnot, in sprint, or have a sprint maybe every 5th sprint or whatnot, we're going to clean up. So every so often, every 10th sprint or something, put that sprint in there before it becomes a nightmare. Because if you spend 2 weeks cleaning up, and if you budget it appropriately, management will buy that. If you all of a sudden come to the manager and say, you know what, I need to clean up, they're like, well, you didn't plan for it, so plan for it ahead of time. This is my last slide. Just kind of recap of what I said. Find noisy tests, get rid of them, and write the good ones. We talked a lot about the unit testing. I'm personally very passionate about unit testing and about testing frameworks. So I'm always curious about those solutions. With that, I think this is the last slide. Any questions? Yes.
This is so far back to the concept. How do I evangelize to developers who do not see a need to perform unit testing? In some cases, I have developers who abdicated entirely and said, well, this is too complicated. There's something before me and something after me, and I can't do this. And what they're really saying is, I'm unwilling to spend the time to stub, and I'm unwilling to analyze the output and make a call on my own.
Good question. Good question. So you have to bring the question was, I don't know if you guys heard, the question was, how do you convince developers to write unit tests, right? Okay, so I think convincing is the wrong word here. I think you have to make the developers part of the process. So bring the developers and say, hey guys, let's establish some metrics. Let's establish quality metrics that we're just going to maintain. So how do you propose making this code high quality? And just turn it over to them. And you will see that some of them will say, well, I don't know, we need to test that. Good. So how are we going to do it, right? So just turn the tables. Because make them part of a process. Let them tell you they want to write unit tests.
Essentially say, how would you like to be measured?
Exactly.
And let them come up with the answer.
Yes, absolutely. And then define those quality metrics and monitor them. Let's say, okay, now every build, you said that you'll achieve 80% of code coverage. Great, you said that, not me. So I'm just going to monitor that, put it on a nice dashboard, and come in every day. And when I see the code coverage metric or assertion failures below the rate that you and I agree, we're going to have a conversation. That's all. Thank you. Yes?
When you mention noisy tests,
Mhm.
I suspect that you mean more like irrelevant tests rather than what's called flaky tests or tests that are
Unstable.
non-deterministic, or the code is non-deterministic.
Mhm.
How do you normally recommend people to deal with undeterministic code?
Undeterministic code or undeterministic test?
How to set up the test and which assertions to write.
Mhm.
So the test ideally keeps passing even if the code behaves differently every time.
Code behaves differently every time. This is
Non-determinism. Tests interleaving.
right.
random generators.
We had that problem actually. We had that problem in my previous life. Some of the tests were depends on when we would inject that message, and it was undeterministic. So one solution, it's not an ideal situation. You know, threading is just timing is a problem. So timing, we introduced the concept timing. Normally introduce the concept of timing at the functional tests, not at the unit level, right? So the unit level, if you wrote them, they're pretty freaking stable because there's no thread issues there for the most part. Timing comes when the functional tests are written. So my solution to that would be give it a range. Don't precisely say it has to be in 500 milliseconds or else. Give it like a range. It has to be, the event has to come somewhere in between 450 and 500. This way, you kind of give it a range, acceptable range, everybody agrees that you're done. But it has to be pass or fail. So it passes if it's between in the range. It has to be a binary decision. Did your test pass or fail? That's the goal. How you get to this goal, I don't know. It depends on your problem. Yes?
Timing element made me think of runtime for unit tests.
Mhm.
Do you constrain those at all, or do you recommend we constrain them?
I recommend running them. So the official recommendation, the official is the tests have to pass, like have to run in like under 10 seconds or whatnot. So the official recommendation from the industry is they have to be very, very fast so people would actually run it. That's an official. My personal opinion, I don't give too much thought about it. It's like our unit tests were actually pretty freaking slow because they have to run on some special hardware. And we would run them every night. So I had 12 hours at night to spend on unit tests. So there's official and there's me. Did I answer your question?
Yes.
Yeah. Thank you for a question. Yes?
How would you feel about a test that, like a functional or a regression test that started inconclusive, where say it was a pretty complicated test and it couldn't say, like, well, I can't say for sure yes, I can't say for sure no. It's like it's in a state where I can't tell. Would you think that? Would you consider that a noisy test that needs to be eliminated?
So what do you mean, expand on this? What do you mean you can't tell?
I mean, there's times when assertions are whatever you write, but
Mhm.
you can also start inconclusive on certain things. So you can say, well, based on the state that it's in, like, well, I can't say what I tried to trigger happened because of what I did, or it happened somewhere else, or
So is it an automated test we're talking about or manual?
automated.
If it's automated, at the end of the test, it should give you a pass or fail result.
Okay, so you don't see a value in
No, I see the value in the test, but then I wouldn't call it automated. I would call it manual. Because you have to make manual decisions based on some test runtime characteristics. Then I would consider that as being manual. If you want to fully automate it, there is a good argument for manual testing. People should still do it, in my opinion. But you have to justify it for the business. There's a very good argument for test automation. So some problems cannot be automated, period. It's just hard or stupid, like clicking, buttons, whatever. It's just hard problem to automate. Then people do it manually, and that's fine. So in your particular case, maybe the problem that this test is solving it requires some manual attention and it requires some of the human interaction there.
But say it could determine sometimes that the right thing happened.
Yeah. Then it's like my sister, right? I call her sometimes. She's like, I don't know. So it's non-deterministic. It's non-deterministic. I don't know what to tell you. You either have to fix it to be automated or keep it the way it is. Is it a good idea or not? I don't know because I don't know that test and I don't know what it's testing. So it may or may not be a noise. But personally, I would not, as a management, I I wouldn't be happy releasing a product to my customers where I know some tests are sometimes passed, sometimes fail. What the hell does that mean? So as a management, I would be very questioning that. Yes, other questions? Yes.
Why were you surprised to see the developers in the class?
Because developers hate testing.
You were surprised in the beginning, like, what are the developers doing here? Like, why were you surprised? Because it's all about...
It was a joke. So I'm not surprised to see developers at development conference, period. I'm not. So yes, thank you. Any other questions? All right. Thank you very much.